Hi, in this video, we're going to introduce single area OSPFv3. So there we are, one of several routing protocols for IPv6. And we're specifically going to look at OSPFv3 here. OSPFv3 with address families, by the way, supports both IPv4 and IPv6. The basic operations that we learned about in OSPFv2 for IPv4 also apply for OSPFv3 for IPv6. All right, so here I've got a table that shows OSPFv2 for IPv4, what I call traditional OSPFv3 for IPv6, and then the newer OSPFv3 for address families. Okay, show the three versions there. Okay, now the routes advertised, so if you notice V2 is for IPv4 networks, OSPFv3 is for IPv6 networks, call them prefixes, and address families includes both the IPv4 and IPv6 prefixes. All three are link state routing protocols. All three use cost. Cisco uses bandwidth for the metric. All three support multiple areas. All three use a 32-bit router ID. And all three support designated and backup designated routers. Okay. You'll notice here for OSPFv3, both traditional and address families, everything is sent over IPv6, which makes sense for traditional OSPFv3. Also makes sense for OSPFv3 address families, even when encapsulating OSPF for IPv4 messages. Those are sent over IPv6. Okay, that's for another video. Or take a look at my book on the second edition or the video series from Cisco Press. Okay, anyway, source address. Okay, OSPFv2 uses the IPv4 address. In IPv6 routing protocols, we use the link local address as the source address. The destination addresses, we can see the multicast for OSPFv2, similar for traditional and address families OSPFv3. It uses FF02, that's multicast with link local scope. I mean, don't route this, but it's the :5, which matches the 5 in the OSPFv2. Okay, similarly, we have the all designated routers, multicast address. Okay, destination addresses, unicast are typically the link local in IPv6, and IPv4 is just the IPv4 address. We will see that we require the IPv6 unicast routing command anytime we're enabling an IPv6 routing protocol. Okay, all three support some form of authentication. And all three, well, they all use LSAs, of course. Let me just show you a brief difference here. Over on the left is the LSAs for OSPFv2 that we've talked about a little bit in in previous video, and I'll be talking about them in other videos. And the right there are the OSPFv3 LSAs, and in red we see two new ones, and we see two that were renamed. Okay, so comparing the two protocols, OSPFv2 and OSPFv3 without address families, OSPFv2 has a neighbor table, link state data table, link state database, which offers the best path to the routing table, the IPv4 routing table. In OSPFv3, we have a neighbor table, a link state database, which offers then the best path to the IPv6 routing table. Just a side note, OSPFv3 with address families actually has a single neighbor and adjacency tables for both IPv4 and IPv6. Again, the book, video, and I'll probably be doing other videos if you would like more information on that. Okay, in our network here, we have an IPv6 network. Some basic configuration here. We have R1, R2, and R3, which are part of our Area 0 OSPF domain. R1 has an upstream provider, ISP, and has which we are going to configure a static default route pointing to ISP. Okay, this is required, IPv6 unicast routing. Without it, you cannot configure any IPv6 routing protocols, and it will not forward IPv6 transit packets. This command also starts sending out router advertisements out any local area network interfaces, Ethernet interfaces. To enable OSPFv3, we say IPv6 router OSPF, in this case 2, which is our process ID. Again, locally significant, does not need to match the other routers, but should. Okay, there's our router ID. Okay, uses the same process as OSPFv2. The router ID command is required if you don't have any IPv4 addresses on this router. Okay, and iOS will warn you as such if you do not. Passive interface gig 00 because we have an interface gig 00 without any neighbors. Default information originate, we'll see that that actually will advertise our static default route via OSPF to R2 and R3. Okay, we enable OSPF on the interface. So we say IPv6 OSPF2 area 0. Okay, again, the router ID there, 2. And we'll do that for the other interface as well. Okay. All right. Now, we do not have to do that on our serial 001 interface because we're not running OSPF with the ISP. We have a static route pointing, a default static route pointing to the ISP. Okay, we do the same, similar commands, not the same, but similar commands on R2. And we do similar commands on R3. All right, let's do some verifying on R1. I do show IPv6 OSPF neighbor. All right, and I see the router ID of my neighbor, the 32-bit router ID. On R3, I do show IPv6 route OSPF because I just want to see my OSPF routes. Okay, one thing you might notice is it says, well, let's take a look at some of the information in this routing table. Let me kind of go through this here. All right, let's take a look at all of this here. So first of all, via, and it shows the link local address. So on R2 has the same link local address on both of its interfaces. It only has to be local to the link. So that's a 2 there, right? Okay, that I covered over. So on this side, it's FE80:3, which has to be the same, which is the same on both links. But as long as they're different on this link, this is FE80:2, this is FE80:3. Okay, so notice because routing messages, in this case, the 2 network, okay, it's an OSPF, here's the prefix length. Being advertised via this link local address, FE80:2 to R3. So that's the next hop address is FE80:2. Okay, so here's the administrative distance. Here's the metric. Here's our exit interface. Okay, here's our default route. Okay, and this means it's a OSPF external type 2 route. The external type 2 is not important at this level of, but we'll be talking about it in other videos. Here's our default route. Okay, propagated by OSPF, originated by R1. Okay, we see that everything is via FE80:2 because this is kind of on a, sometimes you call it stub router. It has nobody else but R2. Okay, all right. All right, that's just the basics of single area OSPFv3. We got a lot more coming up in other videos. And I would also just like to mention, if you would like more information on IPv6 and OSPFv3, traditional and address families, check out my Fundamentals of IPv6 Fundamentals book, published by Cisco Press. Get the second edition. That has all the new stuff, including the address families. And also did a live lessons video series for Cisco Press that you might want to check out if you want more information on this stuff. All good stuff. Okay, have a great day.